piece of what Mariano was talked about, although I'm presuming you've probably seen some of his work from previous interactions, given that he quoted some of your stuff in his demo.
I've seen a few demos before, and I just got the last 15 minutes
Oh,
on
excellent.
the current one. So I have a little bit of context.
Excellent.
But
So
yes,
yeah,
and
we've got a bonus session then. So we've got two speakers, and I will pass the baton over to you now, Tudor.
well, thank you. So this is a bit of an impromptu conversation, and but I think that the last idea, right? So the like what is an LLM? Does it think? Does it not think? I think it's useless to talk about it particularly, because like most interesting is to use it as a machine that is able to produce you something. And the question is, what is that? And one way to look at the LLM is to look for the answers, like what is the weather? The other way to look at the LLM is to look for questions, not for answers. Because right, so if you have at least these two ways, like there are many ways to look at the brain, but one very coarse grained approximation is that there is a part that creates propositions and another part that is producing sane outputs out of whatever we do. So the LLM only has the first part, or some sort of a first part, which means that you don't want to necessarily rely on it for the answers, but as propositions, well, that sounds kind of interesting. So from that perspective, we think that the way of the human to interact with the LLM is actually kind of important, because all of a sudden it means that we still have to be the ones doing the thinking or the choice. As long as we are the ones making the choice, then we have to be informed. And then as soon as we comes to being informed, then we are already in the range of user interactions. Now, with Glamorous Toolkit, we already started from this idea of what if every part of the interaction can actually look different. And that is when we say every part, we say every object. What if every object in our system can actually look different? And then the question is, how do we bring that into this new world of how does that one match now with the new world of the LLMs? So I'm going to start sharing the screen. And what we see here is Glamorous Toolkit. But in Glamorous Toolkit, I loaded an extra repository, GT for LLM, that loaded two new pieces on my home screen, on Home tab. So we have the default, the book about Glamorous Toolkit. I have my local knowledge base, but I also have over here a card which allows me to, for example, in this case, connect to OpenAI. So I can go and specify where the file containing my OpenAI key is. I can go and test it. Oh, yeah, it's successful. And then, of course, I can start doing things. So one of them is that one way to start working here is by looking into the knowledge base that comes with it. So there's like a dedicated mini book that comes with this. And so let's start with something really, really basic, right? So what we want is, the question here is that how do we, as I said, how do we mix the two worlds? So a very, very basic way to mix the two worlds is to say, well, can I programmatically at least communicate with the chat and have have an interface with which I can both program, but I can also see. So what I'm doing here is I just open a super basic, very generic OpenAI chat. I provided my API key to it. So I have an inspector here on the right, which, it's just an inspector over the instance of the chat. Now the chat already, if I look at the instances in the raw information, has the client with which to communicate with OpenAI and all sorts of things. But it also gives me a view, which is the chat. So in this view, I can type things like, or I can send a programmatic message like here. So if I now execute this, what happened here is I sent a message, hello GPT, can you help me find my lost keys? And now the assistant basically returned to me. So I actually have here, I have a chat interface in the inspector. Okay, so now, okay, not so. What would be unusual places? I can also ask from here, and then I get a chat back. So this one basically, yeah, I asked what would be unusual places, and I get some answer from the GPT. Okay, so this is some like a really basic thing. Now, this got us thinking a little bit, because if we think about the current proposition of how do you consume LLMs is, well, I go to a chat, which is happens to be a generic chat. And people say, well, you should do work there. But like my work is here where the work is. Like, why would I go to somewhere else to have a to interact with the AI? Why can't the AI come to us, right? And then we have the co-pilots of the world, where we say, well, of course they can infuse it fast, but even when they come and infuse those feedback in, let's say, in a code editor or so, it's always hard coded. Like it's the presentation of how I interact with what the output is. It's kind of hard coded. And so that's kind of like we said, well, what else can we do here? So let's go and do a tiny, take a step further and see how far can we get. So what I'm doing here, and I'm doing now a slightly more complicated. I'm opening now a tutor. Now a tutor is something that we call a tutor, something that has an assistant, and the assistant can have multiple chats on the OpenAI side. So we have a tutor over here. And in this case, I want to create a tutor over a snippet that I just wrote here. So here I wrote a little post basically. There are at least two ways to use LLMs for supporting understanding of software systems. A, use LLMs to generate summaries. B, use LLMs to generate tools with which you generate summaries. And I go on like this. I basically wrote a post. And so now, what I would like now is I would like to now talk with the LLM, but about this post. And when this post is over here, I don't want to find myself copying this over there, do something and then come here, right? I would like to have a single flow. Like I would like to bring the interaction over here. So to this end, I have to access first that little object here. Now, actually, this snippet, if I look at this snippet page, so this snippet is this snippet, the page is going to be the whole thing. So that's what I got here. And if I do this snippet page, children first, I actually will get that snippet, right? I actually get this snippet. So great. So now that I have this snippet, I can, I do a little bit of things around here. Like this is how you, if I give you this snippet, this is how you get the string out of it. Because eventually when I send it over to ChatGPT, I have to just get a string over. And then this is, if I give you something, if I give you a string, how do you change the contents over there? Okay, so once I have this in place, I'm then going to create a chat. So let's do that. So now I have, again, I have an instance, I have an inspector over an instance of a chat. This is a generic chat, and just this tutor that I created here is absolutely a generic tutor. There's nothing particular special for it, right? Now, this chat over here has an instance. So the instance a bit which we're talking about, which, Mariana was talking briefly before about the context. Well, context, we can represent it as an object. We can put all sorts of things in our object, but basically that's the thing that we want to talk about in this particular case, in this particular interaction. So of course we can start to look at the instance and have a chat interface underneath it, but let's just look into the chat. So we just know this chat talks about an instance. Now there's a bit more to talk about here because this instance came with a certain set of instructions. There's already a prompt when I created this chat. So if I look into the instructions over here, you can see there's a rather elaborate, structure of this. So let's read this one a little bit here. I basically start with some generic description of how do I want the interaction to work. I describe what the interaction rules should be. Then I have these things called components. Now, components are like pieces of a puzzle, because now the way we want to communicate with the OpenAI API or with ChatGPT, essentially, we want to communicate with it not with just plain strings, but actually structured with some JSON defined by some sort of schema. And this is a more recent possibility, especially with ChatGPT. So that's what we want to do here. And then so essentially the schema out of which this the pieces out of which that we want to use when we communicate with ChatGPT we call those components. And we can have, at the moment, we have an action as a component, a text as a component, a post, and then we have the actual actions. So actions are things that we want to do with GPT, right? So we want to tell GPT, well, for example, just answer any chat request. And then anytime we provide one of these, we also have to give some examples. So one example here is, if I can say, how are you? I want you to answer as a something, right? So this is an example of how you could potentially interpret this action over here. Okay, so I have this chat, and you can see I already have a default tab here which says with one action, which is the default answer, chat request answer. So I have my post over here, and let's say we want to say correct the grammar. And now I say, okay. So now I'm just sent a message. Now, this time, I'm not just showing strings. I am showing a full inspector, because why shouldn't I, like if I'm already in a chat and I already have an object representing the message, what if I'm showing you the inspector? So for example, here we can say, well, okay, this is the JSON data that is being transmitted. This is the logical thing that I want you to do. That's basically what I typed, but that's the technical part of the message, right? So we can see there's an action part with the thing that I typed, and we also send as like an argument, like another piece, another component is the post. And then if I look at this, is the string that we obtained from the post. Okay, and then I get an answer back from the assistant. So now it's, of course, I can take a look at the JSON data here, and I can say, okay, I have an action, and it returned to me something text, and maybe these two are the same. I don't know exactly what's in the post, but it clearly put something new in the text. And because it's in the text, I also have a default view that shows me here that. But I don't want it to put it, randomly in some in any part of the data that it wants. So I should maybe say something, correct grammar, put result in the, or put the result in the post property. So let's see if this is better. So now I actually I wanted to instruct it. So I'm gonna collapse this. I want to instruct it here. I give you this. So correct grammar, put the result in the post property. And I hope that when it comes back, I get a JSON data without. Let's see. Here's the corrected version. There are at least two ways. It didn't know how to do it. That's interesting. So now this is the moment where you start to beg the GPT. Maybe we can say, please put the data not in the text one. Well, let's see if this works. So this is kind of typical, right? Here, like you want the machine to do something for you, and you're trying now a few prompts. And I don't know. Let's see what it does. Let's see if it behaves today, or if you're close to the. So we can see, okay, got back some answer. Oh yes, now it listened to us. So we say, well, answer this one. We want that chat request, and then it says it puts here the result. So great. Now
Is
we
that,
got
is
it
that plead driven programming or something? It's like
exactly no prey-based programming, like the another variation of it. So we got it to do what we wanted, right? So that's excellent. Now I have this new proposition. It's right here. I can go and read it. But the problem is that now, how do I compare it with the original one? So if I look at the original one is over here or over here. Now, I don't want to compare things by, reading them, because it's just a block of text. Instead, what I would love is I would love to have a diff view, because that would be much more interesting, much more interesting way to consume these ones. Okay, so now that's the moment where we have to now start to go a little bit deeper into what we're having here. So what do we have here? You can see there are a few buttons here, and these are, so one of them is this, right? So I can go and inspect the object behind this message. And I can see here I have a GT OpenAI action thread message. So a generic message, which can, of course, gives me some of these views that I have there, JSON data, the action, and so on. Right, I can see the content as a serialized version and so on. Okay, but I don't want, I would like to have my dedicated, I would like to have my dedicated object here, my dedicated message. So what I will do is I will say, well, you know what? Let's reify this. So instead of having a generic message, I want to create my post message. And instead of just a generic tutor, I will create my post tutor. I'll put it in a demo package. So I want to create two new classes, but I don't want to change. I don't want to stop and redo. I'm already in my context. I'm already working what I would want to do. I want things to change while I'm working. So now if I'm now inspecting again this, I can see that now it's a post message, because we basically did the forward become, and now this I have an instance of a new class. So kind of interesting, but not really. But now, because now that I have a post message over here, I can do all sorts of things. So for example, here, if I see, oh, this is the JSON data. So if I now alt click on this one, I can see that basically, okay, this is, okay, it forwards it to this one. So content JSON, basically, if I go here, I can say content JSON at, and then I have post. Because that's the zone, that's the one over here, right? So that's the string. This is how I query, I get the string of the result. And then if I look at this one, I can say, okay, self chat. And from the chat, I can go to the instance. So that's the object that I passed in as the context. And then from there, basically, I can go ahead and get the string of it. Great. Now, once I have this, so I have the old version, this one, and the new version, that one, then I can go ahead and create a view. And basically, I'm just creating now a normal inspector view, well, normal for GT, obviously. And this time I want it a title, I want a diff view here, and it should say, well, from, well, you have to put the old version, is this one, and then the two, and I'll put the new version of the text. I'll put it over here. Now I'm saving this, so a diff appears here, which is great, right? It's already nicer to look at this. I can see, okay, using, oh, look, I missed an argument over here. But what I would really like is I would like to have it here. Well, not a problem, because basically now if I do GT LLM message view, so I add one more pragma to it, I tell it, well, actually, why not appear here? And I can close this one, and now I can take a look at this right in place. So that's pretty cool now, because now I changed the, while I was chatting, I'm now changing the I'm changing the interface. I'm changing the way, the means by which I consume what the LLM tells me. And obviously, in the same way, I could also start to change the means by which I generate what I input to the LLM. So I didn't really finish here, because like one thing that I've done here is I wrote this, like I went through 3 versions, like correct grammar, and then I did put the result in the post property, and then I backed it more nicely to not in the text one. So that's kind of nice. And I like that. I like that particular prompt. So why not remember it? So here I have another little button here which says, well, let's reify the action. So, and the action is one of these. So I really want to have a new button here, which basically should say correct grammar. So now I say, well, correct grammar. And the interesting thing is I already populated the description here, and it already has a set of like a basic example. Where did it get the example from? Well, from the conversation that I just had. So I take the context of the chat, and from there, I'm now creating a dedicated prompt with the example already being populated. So now if I say okay, then all of a sudden, boom, a new button appears here. So next time I want to look at this, right, I don't have to type all that, magic prayer. I can simply say correct grammar, and it automatically does what we want it to do. Um, and from there, now we can say, okay, correct grammar, and it corrected the grammar. So we went from a complete generic chat to basically molding the chat while we are having the chat. Pretty much in the same way as we are molding whole domain models while we're programming, because there's no real difference between the two. And the only thing we've done was apply the principles of multiple development, but now to a chat. And so the key here was to see every message as being a little object with its own inspectors that can be extended exactly in the same way as we are extending any other object in our little universe. So once I have something like this, then I can go on and pray some more here. But I've already done it here. So if I now inspect this one, I can see that I have, for example, a create title over here. So now if I say, well, create me this title, it should come up with the title, like something. So a suggestion, I might use it or not. But if I now say correct grammar, let's see if the prompt is as powerful as the one that I found just a second ago. Then I did get this one. I do get a diff differently corrected, obviously. But the interesting thing now is that I also get a little button here. So if I now inspect, I'm now alt-clicking on the diff, I can see that there's one tiny extension here, which actually tells you, well, you know what? If I now press this button, go ahead and change the content. So let's say if I really like it, so for example, here, if I say supporting the understanding, supporting understanding. So if I now press this button over here, I can see that it changed there. So that's the core idea. The core idea here is, well, chats are really, really interesting, but why are we not in the loop? Because it doesn't make any sense to go and use a chat just in isolation, right? So we have all sorts of propositions today, again, with just some other magic boxes put on top of these chats. Like, for example, OpenAI just said, oh, go ahead and do work in the canvas. Why would I do work somewhere else than where I really want to do work? And then you have other services which give you hard-coded kinds of prompts, which are nothing else but just some chats, essentially, that you can basically customize. And now here, because here I didn't do anything special, I just use the availability, the possibilities the environment already has. It means that you can start with any context you have, any object you have, and start building, chats around that. And so now this is absolutely not bound to a very specific, um, narrow kind of use cases. Like, this is for coding, this is for, here we took something which is just, correct some grammar or something. You can of course use it to say, well, complete this article with 1,000 more words. I kindly urge you not to do that, because we are already swimming in a ton of nonsense. So adding some more to it won't do anyone any good, but it is possible. And the so now we have a flow where we can go from real work and get anywhere. Because now if in my work I have just a sea of objects around me, I can take any of that, of any object, and defining any context, and now from there have a conversation with the AI and possibly refining or creating an explicit chat around this one, and then have it reusable for next time. For next time I want to work with this. And then of course there is this other thing, which is so we can start doing this for here, for example, we have a tutor that we created in a very similar structure. But in this case, we're basically having a conversation about a method. So for example, here I can have, please propose renames for, so if I take a look at this method, I see here that I have a paragraph and an index. So let's say I want to say, please propose renames for paragraph. And now if I ask it, I'm now, so the message that I'm sending now has the method in it. And then it came back with a list of propositions, which says, well, paragraph, text segment, line, text, character line. Are they useful? Maybe, maybe not. But they are propositions. And if I deem them useful, I can promote them to something. If not, well, no. And then there's another layer, which is the UI. So we can, most UIs that we have built, at least so far, or until recently, are basically just about the human interacting with the content, and basically the UI just immediately acts on the interaction. When it comes to the LLM, especially if we still want to have the human in the loop, then all of a sudden it means that whatever comes from the LLM, we don't want to take it as an answer. We want to take it as a proposition. So now the UI has to change a little bit so that it can host propositions. So how would that look like? So to this end, I'm going to go here in my local knowledge base, and I'm going to say I want to start a wordly map. Now, a wordly map is is a way to describe basically a landscape. So the idea is that you can depict the evolution of a concept or a product, going all the way from genesis to custom built to product and eventually to commodity. And then you depict things here on the vertical axis, or on the vertical. Things that are higher up have a higher visibility than those that are at the bottom. So it's a way to basically make sense of some sort of a landscape. And it can be applied to all sorts of situations and problems. So now we can start, like normally we start with an empty canvas, and then you start double clicking here, and then you start creating your first nodes. So you're going to have nodes and edges there. But an alternative here would be to say, well, what if we ask OpenAI to provide some suggestions over here? So for example, we can say legacy modernization from the point of view of the business. So now we're saying, well, let's communicate with the LLM, and the LLM says, well, I'm thinking. And then now we just asked we asked it to give us some initial things, and when it comes back, we want it to come back as propositions. So here I have a node that came back, but this node is not yet in the map. I have to accept it first, and then I maybe accept this one. So let's see, I have legacy system support. This is technical debt reduction. I really don't like that. And so on. So I could maybe go and accept and reject some of them, or maybe I can go here and accept them all. So now I have a bunch of things. Maybe some of them are meaningful, maybe they are not so meaningful. But at the very least, I was in charge. I was in the so it kind of, I had another diff basically that was being sent to me, right? So now, and I can go on here and say, well, customer experience improvement. Well, actually, could you propose some alternative names here? Right? Kind of like how I asked it to, could you please give me some renames of the variable? I said, well, could you give me some names, some other names for that? Now, of course, now the map that I just accepted now becomes the input, the context that the LLM takes. And now the UI now presents, well, these are the opportunities here. Okay, so you have user customer experience improvements, user satisfaction enhancement. I like that one. And now I can accept it. And this one is the one that becomes, and so on. So we can go ahead and propose, maybe add new connected nodes, and so on. So we can now start to have like all sorts of conversations, but everything that comes back from the LLM is still a proposition. Now, of course, at the moment, it's me, the one that accepts or not. But at the same time, right? So here I can say, well, there are a few of these nodes, and maybe I accept them all, and you can see that they're basically all connected here. Now, I can go and inspect the chat at any time. And this basically gives me a history of, so this was the original one that I said, well, create me a set of nodes and so on. And this was the answer that I got from it. And so I have, and this is kind of interesting, right? Because when you got the answer, now I'm giving it a diff, right? So I can see here the diff between what you gave me and what I sent back because I didn't accept this particular node, and so on. So you can see here now I can go and audit the conversation that happened behind the screens exactly in the terms that I had when I communicated with it at this level, because there shouldn't be any difference. It's up to me. And that's, which is basically, again, it's the whole idea here in summary is we applied multiple developments, all principle exactly as they are, and one-to-one applied to interacting with the chat, and it just works. Thank you.
That's cool. So presumably what you've described here, that could apply to like classes. If you wanted to like pick a name for a class, it would help you. And would it look at like the context of a package and sort of same sort of idea, right?
Yeah, there's no different. There's no limit. So in the previous one here, I started from I started from just some arbitrary object. In this case, it's a string or a snippet, but you can start with something else, right? So in the previous one, I said, well, start from this method. And then I asked it to do something with it. And so now here we don't talk about how do I integrate the LLM in a unique way in Smalltalk, but rather, well, I have 100 different utilities. How do I, create 100 different chats? Little kind of different kinds of chats that might be useful in different kinds of contexts. And then, of course, again, the other thing here is I only used one model, but of course, there's no limitation here. We just used one just for the sake of doing this. But there's if you change the provider of the model, you can go ahead and start exploring with tinier models and have this model over here, the other model over there, and so on.
In
Yeah.
in 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 terms of context, have you played around? Because like, in GT, you've got a particular way of writing code, right? The conventions that you use. Are these models able to pick up that kind of context and give you examples that are in the style of like the GT team?
Also that's a different area, right? So it's more, it goes into how do you, well, not train, but how do you fine tune, or how do you provide in context examples so that to allow the LLM to learn basically from the kinds of things that you're interested in. But for example, we did experiment with providing, for example, a library when it comes to creating views. Views are very specific. They give you, you have a very specific API. And so you want to tell the LLM about these APIs so that it can learn about it. And then you can use that particular model for it. But so there's a lot of work that is possible there, but this is basically orthogonal to what
Right.
we're saying here, because we can take, there's a whole lot of body of work that takes place today elsewhere, and we can take all that lesson. But the one problem is not really addressed anywhere. I haven't seen it being addressed anywhere until now, is how do we take this one and empower the human to start utilizing it in basically in the human terms,
Right.
not in the provider of the model terms.
Question, Tudor. Have you
Yeah.
thought of trying to take your all the chats that are in whatchamacallit, Discord, and feeding them in? Because there's a lot of information there.
For sure. But what we'd really like to do is we would like to get other people to start playing with this, because essentially, right, we're providing a platform, and a platform where people can start to have conversations with systems, and nowadays intersect those systems conversations with generative AI, and then it's up to you to go and explore. We're certainly going to explore, right? So I didn't talk here at all about how would you do RAG, so to retrieve information from the system, given that GT is a facilitator from getting information from all sorts of sources. We can obviously provide the RAG, but we can leave this one for another session. Any other question?
Some of the things that Mariano showed in the previous session, are obviously applicable here as well. I mean, he was taking information and putting it into vector databases to then derive context, I suppose. And I suppose, you're right, you can build that similar kind of tooling, like for this previous thing about Discord, it was like, I think, what did he do? He took the text, stuck it into, I think he said a vector database, so you correct me, Mariano, and then given that, you were then able to provide the context to then ask the LLM for information. So I guess it's building that kind of ecosystem in a GT sort of manner, because I guess you glued a bunch of tools together. Is that right, Mariano?
Yeah. Yeah, that's the thing that sometimes I refer at the beginning, is that even when some people want to say this is a completely new way of building applications, a lot of as Tudor said, like the context is at the end of the day is just text. So where does the context comes from? Can you turn it into text? Can come from a vector database, from a relational database, from a CSV file, from an object in memory, from an API call, from a Google search, from like as long as you can turn it into text, the LLM in the sense doesn't care and doesn't know. So a lot of the data integration, it's just a matter of where do you have the context, but also like where would you like to have it? Like if in Smalltalk it's a live system, so there's a lot of context to take, but which one do you take? How much? How do you organize it? How you present it to the LLM? It's just coding like we used to. So there's a lot of glue. That's what my project is called, glue. That's a lot of glue of basically taking all the relevant context from all the existing systems, some legacy, most legacy, and just turning it into relevant context for a prompt. So a lot of knowledge is transferable, and if Glamorous Toolkit has access to that, it could even, like, if Discord has an API and Glamorous Toolkit has an API and a client, it could just bring the last like 30 messages from Discord as the message was sent. So it could always be live and stuff like that. So that knowledge is transferable. Like if you can get to the data wherever it is and turn it into text, then it can be fed as context to an LLM.
It feels kind of crummy to turn it into text, doesn't it? To have like this rich context, to like map it all down to text, where it gets reassembled into something else. I don't know, just, man, all this compute power. No wonder it takes seconds to do this shit, because it's like just reinventing everything, aren't we? But
well, so that's why having a structured way of the conversation, helps a great deal, because you're not just sending text, but you're sending some text with some description. So it's a little bit of help. But at
yeah,
least on the UI side, on the client side, you can have as rich, representations as you want, right? You don't have to take, and as long as you have a way to map your context into the LLM, and then the LLM's output into your context back, then you have an environment that you basically control. So the difference, right? The here, like the work that I showed here, is not. It doesn't talk about how do you train an LLM, how do you get the LLM to connect to something else. It's really like, how do you empower the human to be at the center and modify the tiniest detail? Because, for example, if I'd say, correct grammar, but then I could have said, correct the grammar or rewrite it in the style of Seinfeld, right? Then all of a sudden it's like a different thing, and it's just mine. Or I'm gonna pre-train a model with all my, I don't know, tweets, and give it, I that's gonna be my model, and I say I'm gonna use that model to rewrite what I want to write. It's gonna be me. It's like I'm gonna control all of this one. So the amounts of combinations here are, they're humongous. So this idea of going and putting all these interestingness and confining into a very rigid kind of UI is absolutely hilarious. But that's the world that we live in today, where things are being provided to you as services, in some applications that nobody
the
can
case
change.
in point, just trying to convince it to put some text into a post element. The pleading bit is just like, damn it, I just want you to put that there, right? You kind of want a different UI to tell it what you're trying to do, right? As a kind of,
Yeah.
There's another like transferable skill, and from my understanding, Grammar's toolkit already has a lot of parsers, which is if you like, schemas and parsers can be used in two ways. First, if you want the LLM to return you something that follows a particular structure, you can say reply with this schema, and it will mostly reply with that schema. And you can then use the schema to validate that what was replied follow the schema. And if not, you can say, no, I got this error, try again, or something like that. But the other one is not only in terms of data, but also a trick is to make it generate a reply in a format that is present in the training set. So for example, it knows how to write SQLite queries really well. So imagine you have some data in memory in a table, and you want the LLM to filter it in plain English. So you basically extract the schema from the table you have in memory, rewrite it as if it was a create table in SQLite, and says, and you ask the LLM, like, given this schema, write a SQLite query to do the following, and you write a prompt. So it replies back with a SQL query, you parse the SQL query and you map it to the API that is used to filter that data in memory that may not be in SQLite. You could also put it in SQLite and query it in memory, but that's the thing that is kind of on one side annoying, but on the other side is like an opportunity for people that know how to map back and forth from different formats and from text and parse and do stuff like that, which is how do you convince the LLM to do something that you in a domain that you know it can generate and in a domain you know you can evaluate back and like do some work outside, which is pretty like useful. The trick of making it write SQL, for example, some stuff you can parse. It's a trick, and the trick is that basically you are turning things into text and back out of text. So learning how to force it to do something that is more structured than text is kind of an art, but we have this.
Do you think that there's just a glitch in time, though? Are we going to get rid of this? Because again, it feels like pleading, doesn't it? It's just like, hang on, who's in control here? It's like
There's a technique called, I don't know how it's called, but basically like when the LLM replies back, it generates one token at a time. So if you have a grammar, like you want it to follow a grammar, for every token it generates, you can basically follow the grammar and check if it generated the correct grammar or not. And if it fails to parse, you ask it to generate another token. So that way you force it to output a particular format, and that's how structured output works. I don't know if it's a pro or a con, but it gets less creative when you force it to follow a really rigid format. But you can force it to output something that follows either a grammar or a schema, and it's getting better. And that's kind of like the features that all the LLM providers are adding, because it's really annoying to plead to generate valid JSON or something like that.
Okay.
Yeah, I was thinking when Mariano was showing his interface, I was thinking, but I like the tiling window managers. I use that a lot, so it's pretty cool. And I was thinking about the interface of GT because I use that daily. So how difficult will it be to have something like Mariano's? Like, so instead of having this, let's say,
Miller panes.
Miller columns, yeah. Instead of Miller columns, this tiling interface for producing stuff that is, yeah, how difficult will it be to replicate Mariano's interface in GT? Like having stuff that doesn't produce text, but to produce maps or graphics, and has not Miller columns, but instead this tiling interface.
It's just the composition of some objects or some elements that you want to put them in the way you want to put them. So I just showed you, like, for example, a wordy map, which has like a graph, and I can put things on it, and I can, yeah. So that's didn't look like a Miller columns at all. Right? It didn't look like something else.
Yeah. Okay, and this
that's
of flow elements when you have like this, because when you are interacting in Glamorous, you have like by default Miller columns, no? Like this idea of going deeper a little bit and going back and programming, in
Yes.
that let's say column again. But no, I'm just thinking aloud. But yeah, I am thinking about how difficult will it be to have this kind of tiling interface in GT.
Yeah, it's as difficult as one wants to make it. So, but basically, if I show you this, right? If you look at this, this is an interface that an end user can use without any technical background. You can just click and you do whatever. You can still manipulate things in your term, and then maybe we're gonna draw a collection here. Next time we're gonna maybe delete this. Next time we're gonna send something to the LLM, it will take this new context into account. Now these elements here, right, these are just some elements, so you can put whatever you want in there. But the key here is, how do you know to develop these actions that exist here in this menu? Like these actions, how do you develop them? How do you know what's a good prompt, what's not a good prompt, what's an interesting, how do you debug that? And how do you change it afterwards? Because if you don't want it like this, but you want it like that, how do you do that? And that's why this particular, this view of the chat becomes kind of important here, because this is a way to change and adapt the LLM exactly in the way I want to adapt it. And then it can go, we can take this one also to the more extreme. So if I go back to my demo tutor here, I can take a look at the actions, right? So these are the actions that I created. I have create title, correct grammar. And if I look at one of these, right, I can say, okay, look, this is a sea of JSONs here, right? So even for this kind of thing, it's not so nicely readable. But even here, right, we can have, look at this one, this action here, actually, there's a little tiny completion here. So if I look at this, it knows, the editor knows how to connect to this other thing that I'm editing. So I have the ability to change, to also edit this while I'm working. So for example, if I can see, for example, post here. And now if I right click on this and I say, oh, well, you know what, let's rename this format. Now renaming this format means I rename it here, but everywhere else where this post exists and in the other place where the component was defined. But now I can just do it right here and say, well, what is it? And a post, I don't know, entry. Oh no. I'm gonna rename it to post. No, what is wrong here? So I'm gonna rename it to entry. And now if I say okay, I get the refactoring, and this refactoring actually is gonna change, not here, but it will change it in the in this place, in the actual component where it should apply to refactoring. So it's kind of interesting because we can, the whole idea of Glamorous Toolkit is to be able to create or start from the programmer. But we used to have this conversation of, right, like why the programmer and not why the activist or the newcomer in the world of computation. And the reason is because I think that once we can bootstrap things at the programming level, so the programmer can create things that programmers need when you need to go and work at the level of the machine. Then you have an interesting infrastructure afterwards to build as complicated interfaces so that you can get into this world, but underneath you have all the tools needed to work and modify at any level you want to intervene.
Okay. Cool.
Other questions?
Maybe a bit of a silly observation, but there's a very, I say, widely view that with, oh, sorry, with, I have a question, I have a problem with the other machine. With LLMs and with artificial intelligence in general, programmers will have less and less relevance. But actually, we have more work with this. Now we have to decide where, how to interact with the LLM, what Mariano was saying, whether you are writing these parsers or not, how to interpret. That's my 2 cents. Sorry.
Also, so the way I look at it is, so if you just use the LLM as it is, it comes back with a proposition, not with an answer. You can take it as an answer, but people take all sorts of things as an answer. For example, people go and ask, so why is it taking so long to migrate this to a new technology? And somebody says because of that, and people will believe that reason, and everything goes ahead. So we are used to taking all sorts of answers and base our decisions based on all sorts of things that are more or less real. So one more in the mix is going to make it really an interesting. It's really going to make it an interesting world, but it was not going to solve the problem. So as
Yeah.
long as you take the LLM as an answer, it's not going to solve the problem.
An
in the
interesting
current
question.
form.
An interesting question is to show what Tudor did and ask different people if they thought he was programming or not, because the key there is what does it mean to code, and Tudor wasn't like programming in the sense that people currently the mainstream thinks programming is, which is writing text in a text file. Like he was interacting with things, reviewing, changing, going back, going forth, clicking around, and I believe that the task of programming is going to change the meaning, and we are going to still have programmers, and we are going to still say we're programming. But what we are going to be doing is going to be closer to what Tudor was doing, that like writing text in text files.
Yeah. On the other hand, like most of my programming looks like this. Maybe not entirely like that, like not by reviewing text and so on, but it basically it looks like that. It's just playing with inspectors and changing, going from one object to another, playing again with the inspector, extending some of the code, and where the ideas come from. That's a separate thing. But to me, the LLMs are much more interesting as a source of questions rather than as a source of answers. So questions that you want to go and validate, obviously. So that's an interesting thing. The other thing that I think is very interesting is to take them as a source of generating simple tools, or shallow tools, as I call them. These are tools that you can quickly look at, evaluate. So, for example, a view over an object is such a tool. Then you can use the output, but without. So essentially, the tool that is being produced by the LLM would expose the bias the LLM has. And then you can agree or disagree with it. And then if you agree, then you can go ahead and use it directly, because most questions about systems do not really require probabilistic means to get the answer, right? We can just go ahead and get the answer. So, for example, the weather at the city, and in the city is not what do you think the weather is like? What do you think the temperature is? Right? So you're gonna go and query a specific API. The question is only for which city, right? And this is what you might take the LLM for. And this is very nice. It's very interesting. It's a very interesting combination, I think. But it definitely does not eliminate the programmer basically from the equation.
No, but I mean, before you have to decide whether what you put in the client, what you have in the server, where your story. Now you have to think how I interact with the LLM. That's what I was trying to say before.
I will say that it showcases the conversational nature of programming for more people, because this idea of programming as conversation is something that small talkers had a long time, and in experiences like Glamorous Toolkit is even more evident. But I think that the knowledge needed for creating that kind of experiences, or the experience that Mariano show us, it requires the classical programming in a sense, because you need to build interfaces, but it will showcase this conversational nature of programming in a more explicit way.
So, but for example, now the LLMs know about SQL, they know about schema. So as you, Mariano, say, if you have your schema and you have it with comments, then it's better, because the LLM will be able to produce better queries, or make the translation from SQL to natural language more easy. But let's presume that it's not SQL, but you have something similar, and you need to you need to interact with that. So you need to write some sort of, well, what you said before, some sort of parser to understand in your system in order to I'm not explaining it well, but
it's kind of what the same that Tudor was doing, but in more general. Basically, what you have to do is kind of model the domain and expose it as like declarative tools to the LLM, And when the LLM decides to use one, you received which one and the arguments, and then you map to your system. So that's kind of what Tudor was doing, and kind of what glue data is. It's basically it's a layer in between the LLM and your systems, and a way to expose the capabilities you want exposed in a way that the LLM can understand. And that usually right now looks like it's what's called tools, which are basically actions and arguments that the LLM can pick, and then you map that. You map that into your existing tools. And also the thing that there are many like text to SQL, as they are called. The problem with that is that many times the domain knowledge of the constraints of what to use when is not encoded in the schema or in the comments. It's encoded either in some internal wiki or in the head of a developer or some Java code. So the LLM is never going to know about those like specific things about that schema. So it's probably not going to generate the right SQL. But the other one is that usually any like core data system you have, like a relational database, it's always accessed through like a middleware, some system that runs on top. So if you allow anybody to run queries against your relational database, you have the problem that you're skipping like permissions and access and login and audit and like which tables can see who and like limits. So basically, if you it's really easy to expose like the schema of the database to an LLM and make it run queries against it. The problem is, other than not writing a select and writing a drop table, the other one is maybe it will generate queries that leak data that the person running the query shouldn't be able to see. So I think that the right way to do it is always to have like an intermediate layer that does the translation between what's accessible to the LLM, who can run it, and then go through the standard paths that are like exist for a reason. Who can see what, like logging and permissions and access and quotas and rate limits and everything we have built over the years.
Yeah, thank you. Very, very clear.
I didn't come across very clearly. Could you repeat? I think there's a sound microphone problem there. Perhaps you can type your question in the chat and we can read it out for you.
Just to add, I pasted a link to an article and a presentation called Home Cooked Software and Barefoot Developers. This is also another opportunity that opens with this, is that like it's kind of not dangerous but hard, because like LLMs can generate code and you can use LLMs to help like non-developers or junior developers generate code that otherwise they wouldn't be able to. The problem is that what happens when they generate code that they cannot read or change, or it fails and they don't know why. But there's an opening for end user development or like low code development, or what's called here like barefoot developers. That is a possibility, but that's the thing. Like if I say something in English and it generates a SQL query and then returns a result, the same way that if it generates text and I cannot tell if it's lying or not, how do I know that the SQL query that it generated is correct if I cannot read SQL? That's something that is hard to make people understand, that the ones that are hyping it a lot, is that how can you trust something you cannot understand? Like you have to just trust and hope. The problem is not when it doesn't run on where it's clearly wrong. The problem is that when it looks right, but it's not. And like we will have to learn when to use what and build tools to like validate or verify and stuff like that. But yeah, it's a potential opening for this.
How
think
much
that
time have you used an LLM to create the tools that you're presenting here?
Want to go
What
first?
was the question again? How many
I mean,
LLMs did we use on the production of this?
with
No way.
these tools, with with hooking up an LLM and the ability to ask questions, how much are you using it in your development of Glue and GT?
So the use case of correcting my grammar is an actual use case. I have that problem and I wanted to correct my grammar. So
Yeah,
that's an example.
in my case, where I see it works is where I use it the most, just is basically data wrangling. Like I have a CSV and I have to turn it into a Parquet file, or I have a CSV and I want to put it into SQLite database, or I describe a schema and I want to write the create table, the insert, the update, the delete, and the select. And I want to create functions so that I can call it. And also the one I use it the most for is CLI parsing. Like I hate to write the code to parse CLI options. And it's pretty good at writing that. When you go further into more complex domains, like in codes and APIs that this doesn't have access because it's your own code, or you are using libraries that are not well known, or in languages that are not well known, it's not that useful for me. For example, the other way I was writing Rust and I had a borrow checker problem and I asked the ChatGPT to fix it and it wrote like 300 lines of code. And the fix at the end was moving one line from one function to the other. I don't even know if the code that it generated was right or wrong. I just didn't want to add 300 lines of code to fix one line issue. But and that's why it creates this false impression of being like a senior developer, because it's really good at writing like data wrangling stuff, Python, JavaScript, and React.js. And but once you take it to more like complex domains, existing code bases, smaller programming languages, or like APIs and assumptions that are not available either in the context or in the training data, the code that it tends to generate is not that good. So you can use it to get some inspiration or to learn about an API call that you didn't know it was there. But I just use it for that mostly, data wrangling, like small CLI tools and inspiration. But I don't use it to write code of Glue data for, because it doesn't know like the structure of my code or the APIs or the way I design the application.
Although it could do, I suppose, if it had the right context, but it's
Yeah.
taking the time to do all of that, I suppose, is the
Yeah.
But again, like the question is, writing code hasn't been a problem in software engineering for a few decades, good decades, for the most part of the last century. Reading code, on the other hand, that's the bottleneck. Now, if you're going to write faster, what do you think is going to do for the actual problem?
yeah.
It's
Make it
just not
work,
going
yeah.
to solve.
And the other thing is, sorry.
We are already in a world where the code is getting written somehow by somebody else, right? And it doesn't matter whether that somebody else is a human or ChatGPT. What matters is like how fast does it grow and how quickly does it overtake my ability to reason about it, right? Now, most systems today, and given the way people reason about systems, is that most developers live in a world where they cannot understand their own system. That's the problem to solve, not the other one. The other one is really interesting for the first 5 minutes, but when you have to, for the rest of the few decades, it's less of an interesting problem. So that's why I think that the way to look at the LLM is to use it for asking questions, which it turns out, when you're building tools, the bottleneck is actually not how quickly you can go from a question to an answer, but how quickly can you come up with an interesting new question. So the
But-
divergent nature of the LLM is actually kind of an interesting thing. The other utility of it is that any proposition, right? The question is how quickly can you evaluate the proposition's validity or interestingness? So the reason generative AI got traction in pictures and then movies and then, or no, pictures and then short chats, and then movies, is because those are the kinds of things that we can innately evaluate. Very quickly can we evaluate, right? With code, when I see people just take a prompt and then a few pages are being written there, it's just like, this is ridiculous. This is exactly how, the kind of thinking that creates the business, or the kind of, creates the work and the kind of business we earn our funding from. So, it's really great because people just add fuel to the fire. So I don't see that to be the direction. However, using LLMs for shallow problems, so problems that we can very quickly evaluate, is, I think, very interesting. Small problems, and that's the reason why, like, the moldable development gives us a very interesting opportunity, because with moldable development, typically split large problems into really, really tiny problems. Well, basically, I have an object. How do I view this object? Can you help me view this little object? Basically, this is really a lot of the work we do when we reason about all sorts of problems in systems boil down to. So, and for that, LLMs are very, very interesting because they're very good at producing things that we can evaluate quickly. Of course, the evaluation doesn't have to just be the innate value evaluation. It can also be helped by the environment. So this combination then makes it much more interesting. But then again, there you might want to have lots of very highly dedicated kinds of interactions with the LLM all the time, going back and forth, which is the reason why we wanted to say, well, how fine grained can we control the interaction? That's the direction, I think.
Also, there's something I've heard others say is that they when they are either forced by, like, I don't know, external pressure, or they feel like they have to use AIs to code, or they use Cursor or some of these programming tools, is that even when you usually say, like, more than 50% of the time we spend reading code, they say that their job is to prompt and review code. That's the cycle is you prompt the LLM and you review code. And many said that the part they like the least about their job is to review pull requests. And now programming seems to be like a constant stream of reviewing pull requests from an LLM, and that they don't enjoy it a lot, because the part that they liked was the writing of the code, and the part that they didn't like was the reviewing of the code. And you're going to see, like, it's the usual pull answer when you submit a really big pull request. Somebody says look good to me and merges, is that people are going to just stop looking at the code even if they can, and like the technical debt is going to explode in a couple of years, and Tudor is going to have a lot of work too.
But the thing is that people already are not reviewing the other people's work, because this is how you get to humongous systems that are everywhere. So we once looked at an organization that they were having into many thousands of systems, and that they were looking into generative AI to create systems faster. And we looked at it and said, are you sure you have that problem? You don't seem to have that problem, but
Don't you want an LLM that removes code instead of that? Right.
Yeah, that's kind of more interesting.
I think the quote you're searching for, Mariano, was I want machine learning to do the dishes and wash the laundry, not do my painting and my writing. But
yeah. But
a very interesting perspective, guys. We got any other questions? presumably that act of reading code, it can help you summarize. You know, it is quite neat when you've been in a meeting and you say summarize the meeting, and it sort of calls out, you know, the salient points, which it actually does a fairly good job of. Actually, what I've seen from Copilot, I've not really had much chance to experiment with how to summarize packages of code or these sorts of things. I think the GT one does do that, doesn't it? Did I see that briefly a while back, Tudor, that it will look through code and sort of, presumably it could draw you a diagram and have a go at telling you what things do, or is that anything that you've tried?
As I said, like asking the LLM to produce the picture directly. So I ask the LLM, what's the picture of this? And then the LLM gives me back an answer, or what's the summary of this? And the LLM gives me back an answer. That is an opinion. It should not be the basis for decision making.
Yeah.
It is the basis for evaluation, which is interesting. Could be interesting potentially. However, if you ask the LLM to give you a tool with which you run and draws the diagram, that is much more interesting, because then I can inspect the bias into the tool and I can adjust it. It does not preclude me now from understanding what the language is and how do I construct a tool like that. It can help a little bit providing ideas about that tool, or maybe shortening a little bit, maybe the work, but that's the irrelevant part. More interesting is the suggestion part, the fact that you can get unblocked by just generating some alternatives that you might not have seen. So that's how I look at it. So asking the LLMs for summarizing the code is, in my view, not a really good engineering practice.
Or is it's a good first approach? Like if it's the first time you have a code base, you can say like, can you, I don't know, point me to the file that does X? But it's search. It's not like it shouldn't replace the thinking.
It's not an answer.
assist.
It's not an answer. It's a question. It's like,
Yeah.
maybe here, but I don't know.
Yeah, maybe. But
Yeah,
that's
doesn't
the
matter in
problem.
which.
Many people can offload the act of thinking into the AI, and at least for now, it's not going to work.
Yeah, at this moment in time, there's no second part of the brain. There's just the first one that.
Yeah, I am actually using Copilot, and I sometimes ask it to explain. So my situation is that I'm looking some Python code, I'm not very familiar, so I do the explain and it gives me a summary, and then I can go and look a bit further, but it gives me an overview. So I think I'm still amazed that it can do that.
Yeah, it's like I heard many people said, and I kind of agree, it's like a super energetic junior developer. At this point, it's kind of like that. Like, and if you know what to ask as a really energetic junior developer, it's helpful. If you think it's going to design like a really complex system or do a huge refactor, maybe you're going to realize sooner or later that wasn't a good choice.
Oh, the other thing that surprised me is that you are in a code base that I don't know, and I need to do a small change. So I open, well, I'm going to do a comment here, and it puts me, yeah, exactly the comment that or one of the comments that I could write. So I say, wow, it's like it's reading your mind in that way.
Or that code was written so many times that it already knows what comment goes there, which is kind of what it's doing. And that's I will repeat myself like for the third time. That's why it's so good at writing JavaScript and React.js, because there's so much of that in GitHub or in the public internet that if you have to do a login form in React.js, it has seen so many instances of it that it's going to write the right one. But if you need to do some tricky stuff that it's like specific to your domain and not really available or really present in the training set, it's not going to know.
But if you want to use the LLM in a like a la Copilot, so not doing any groundbreaking work like you guys are doing, So and you need to work on your code base. So do you need to give your whole repository and going through a training or a phase, or it could work just like it is out of the copilot that comes out of the box?
The tricks that the IDEs like Cursor and Copilot do is they provide in the context the file you're in, the other files you have open, the structure of the file system, and depending on the tool, the high level APIs of the code in your repository. So it provides that as context. So there's a tool like I know one, but there's a tool that you can run, and it inspects your Rust code base, and basically it generates context with just the modules and the functions and the signatures of each function and the structs. So it just doesn't put the code, but that sent us the context for the code you're writing. So now it knows about your code base at the high level, basically only the modules, the functions, the signatures, and the data structures. But that's enough for the LLM to basically know more about the code you're writing, so that it can basically, because your code, unless you're writing like groundbreaking algorithms in some weird niche domain, your code is either like a CRUD app for a bank, or some like workflow data application for, I don't know, like analytics. So based on everything that it knows about the domain, plus the signatures of your code base, it can generate code that is like that makes kind of sense for the problem you're trying to solve. And the more represented the problem you're trying to solve in the training set, the easier it's going to be to generate the code. But then the question is, why are we writing that code again? If it's so present in the training set, why do we have to write it again? And that's like something we talk a lot about in the future of coding Slack. Why do I have to write a login form again, basically?
And is that the context window that you've described there that you mentioned
Yep.
earlier on? Yeah, okay.
But there's one other thing to keep in mind. So when you're asking the LLM to summarize your code, you're saying, oh, this is great. You're comparing that with the alternative of you going through that code in some form. There are much faster ways for the human to go and understand a piece of code than what the current status quo is. So yes, that res summary is going to be better. Having some sort of an answer is probably better than having zero ideas.
So, but
So
what
the
is the
baseline,
alternative? The way of looking.
we just talked about it. It's called moldable development. It's a systematic way to understand any problem about your system. You don't have to believe it, but it's there and it's documented.
No, I believe, but the problem with the
Yeah.
model development is that you need all those tools in your code base, and that's a big effort, no? So
Why? Why is it a big effort? No, it's not. It's much cheaper than any other alternative. Like an orders of magnitude cheaper. So, but again, people don't have to believe it. It's just the way things are. So it's just, it used to be the case, for example, that people say, oh, well, this is so complicated to deploy 10 times per day. We're going to be super happy to go from 1 time per year to 2 times per year. Yeah, it's going to be an improvement. The same thing with that LLM. So if you have 0 ways to understand things, and having some sort of idea is going to be better. Yeah, so the alternative before was, oh, let's go and ask someone that knows about this, and then they will tell you something, and then you will trust what they say, and then change something, and then maybe it doesn't exactly work, so then you'll find out something, and then later you're learning about this. But there's also a systematic way too. So when the baseline is that way of working, then maybe this is an improvement. When the baseline is, there is a systematic way in which I can decompose any problem I look around at, and this is going to be orders of magnitude better than that previous baseline, then all of a sudden the LLM is a decrease in productivity. Asking for that summary is much less interesting than it actually is. So, and then you'll see that there are other alternatives, other interesting paths to use the feedback. Now there's another thing here, which is today people think about a system as just inputs and outputs, right? And people are super happy. So, oh, I get a print. I have this prompt over here, which says I take this input and then produce me that output, and they are super happy about this. I mean, the whole industry ran on this idea of transforming into these inputs into outputs for a long time. On the other hand, any software organization today, the knowledge has the knowledge actually not in documents as people used to think about 40 years ago, but in systems. So another way to look at systems is as encoded knowledge. Now that's a different way of looking at it, because now all of a sudden it matters what's in the black box. You cannot just treat it as a black box, or you can, but you're going to leave a lot of opportunity on the table. And so now how the system then is implemented matters a great deal. And that's another opportunity. And there's a tension here with this measurement of, oh, let's create more and more transformations of input into output without regarding of what's inside. So
We're getting a good variety of answers here. It's quite interesting. It's just when you think it's like, I know the answer, and then it's like, no, there's a different way of thinking about it. It's all context.
Yeah, just as a worse is better remark, people are going to try
Yeah,
to use LLMs for everything. Like it's just going to happen. And
sure.
the thing is that it's more like the paper or article called the unreasonable effectiveness of data, where basically if you throw more data at the problem, it's going to be solved. Like there's going to be like an article called the unreasonable effectiveness of long contexts and LLM prompts. People are going to try to solve it that way and try to convince people that the MIT style of creating better tooling, because like at the end of the day, programming code is something we can build tools and interpret like deterministically. It's a fight we have been fighting, and the Smalltalk community has been fighting for 20, 30 years. But people are going to throw like the New Jersey style at it, and we have to finding the right balance of when to use and when not to use LLMs is a hard one, and convincing people that we can build better toolings that don't require LLMs for everything. It's going to be a hard fight, because we are at the phase where we are throwing LLMs at everything.
Yeah.
And yeah, doing it the other way I think it's the right way, but yeah, we have to do it. And we have to show it by example, by building and by showing them and by explaining it why it's better this way.
That's actually quite a very nice closing remark, actually. I don't know if you have anything else to add on top of that, Tudor, or
no, I think we're fine. People should go and try, and that's why it's important to, but ideally try in your terms. Because the problem is when you start to try in somebody else's terms, that's, people try, it doesn't work, and they don't know how to think about it. But when you have the opportunity to take, it's a really exciting thing. But take it and play with it for what it is, not for what you think it is or for what somebody markets it to be. You basically, you start from your context, and then you see how it applies to your context, and have a direct path to go from the context to that playing around. I think that's kind of fundamentally important, and now you can do it.
so I guess I'll ask if anyone has any final questions. If not, I think this might be a good place to shut down. I know it's quite late for both of you guys, so I appreciate you hanging in there. Any final thoughts from anyone? I'll take that as a good chance to say good night to everyone, and thank you for this month's attendance, and thank you to our speakers, Tudor and Mariano. It's been fascinating. I'm inspired again. I'm going to try and a few examples and take some of this this knowledge and see what I can make of it as well.
Thank you.
Thank you, everyone.
Thank you, everybody.
Bye.
Bye.
All right. Good night.